Hello, ROS developers. Welcome to a new ROS developers live class. Hello, how are you doing, man? Are you doing okay? Hey, you thought it was the chicken that was talking. No, it was me. So funny, eh? Isn't it? Okay, guys, so welcome. We are here back again another week to learn about ROS. I hope that you are ready. Today we are going to do a very interesting subject that it's the beginning, the basis, the foundation for making a robot navigate in any environment by creating a map, okay? So we are going to use SLAM techniques. And this is the basis. So today we are going to learn about how to create a map and then how to localize the robot in that map that we have created. So that's for this class today. And we have a lot of work to do. So I think that the best thing is that we start. But before that, let me tell you that I've seen on the chat that there is some people that have some problem with the time of the live class. So I think that unfortunately in some countries during this week, it has changed the time to summertime or something like that. But in the place here in Spain, that is where we are doing this live class, nothing, so the time was not changed. So that's why we are doing at the same time, 6, and even in the same time zone. So it's CET actually. So I'm sorry for all those of you who has missed the class or you got confused about the time. Sorry for that. Maybe we'll take into account that in the next live class, and we'll put some comments on the community tab of the YouTube channel. Okay, so you know that there is in this channel of YouTube, in the Construct channel, there is a community tab. And sometimes we put there some polls in order to know your opinion or some interesting things there. Also, we'll put there a notification about the changing of the times or something related to that, so you don't get confused. Okay, guys? Okay, let me see who is here before we start. Let me see who is here, because I have seen that many people were there waiting for the class impatiently. So let me say hello to all these people. Gloria, who missed the class, I don't know if she's here again. That one of the people who had this problem. Then there is Rakshith. Nice to meet you, Rakshith. Akash. Also, hello, Eneko. Hello, Eneko, how you doing? Escamiambas, hello again. Junjuan, of course, hello again. And Stefan, Haro, Gloria. Oh, Gloria is back. Okay, very good. Gloria, happy to hear. Uchena, nice to meet you. Uchena, then ROS Agriculture, that should be Matt, probably. Nice to meet you, who are you from ROS Agriculture? I think it should be Matt. Then Danny Dash, of course. Danny, how you doing? Akash, Nico, and Lagan Kapoor, one of our ROS ambassadors when we had this program about ROS ambassadors. So Lagan was one of them. And also James, finally, from Tamil Nadu. Okay, so I don't know what is that. It looks like for me to India, something like that. And you deleted the message right now. Okay, no problem, no problem. And hello to all the other people that is there, but you are saying nothing, no problem. You can stay there watching, interacting. But remember that if you have any question during the whole live class, go to the chat and ask the questions. I will be checking from time to time and then answering your questions, okay? Don't wait until the end. If you have a question now, do it. If you have a problem, then just express there. I'm not following. I have this problem. It doesn't work for me. So let us know. Okay, so we'll do the best. And there was one question at the beginning of the chat that says, oh, but how are we going to get this ROSject for the class today? So for all of you who doesn't know, this class is a live class. It's a class where you are going to practice with me what I am teaching you, okay? So you are not going just to listen and that's all. No, you have to practice, okay? So please practice. For that, I have prepared what we call a ROSject. A ROSject contains the simulations, the code, the notebook, everything, so you can practice with me at the same time by using the ROS Development Studio, who is a tool that is online, and we only need the browser. So you are going to need only the browser and the ROSject that I'm going to share with you in a minute. How do I share this with you? Well, by providing you a link. So I'm going to show you how to do that. So in case that you create your own ROSject, you can also share with the community, with your friends, with your colleagues, with whoever you want. It's the same procedure, okay, so that I am doing now. So you can do it with your own ROSject. And let's go with our ROSject for the live class of today. So let me share with you my screen, and then you will understand what I mean about the ROSject. I understand that sometimes it's a little bit confusing because it's new, okay? So let me just check the chat. I see a lot of people here. Then it says +1 for ROS Ambassador, Matt, okay, Matt, very good. There is 37 people watching right now. Don't forget to click the like button. That's Gloria saying yes. Thank you, Gloria, for promoting. But actually, it's 43. Okay, so it's increasing. Guillermo, hello. Akshat already said hello, I think. Hello. Naman also, I'm making humanoid robot. How do I stabilize its body without using simulation? Okay, Naman, sorry, I cannot answer that question because it's not related to the live class. Put it on the comments of the video, and then I'll try to do my best, okay, afterwards. And Lawrence from Georgia. Commander Cisco, we were missing you, so now you are here. Very good. Let's go. Let's go. We have a lot of work to do today. So let's start sharing the screen. So probably now you can see my ROS Development Studio tab. And yeah, so I already opened, but let me go to my ROSjects. So if I go to my ROSjects, here I have many ROSjects about different things. Of course, the live class that you already know, but many other things. Today, we are going to use this ROSject here. And how do I share? So if I have created these ROSjects, how do I share? Very simple. Press here, share. And then shares, oh. Okay, so it should not be like that. It should not be in, this is because it's public. But anyway, very simple. Copy link, copy it, and I'm going to paste it on the chat. So let me put it here on the chat. Here. Okay, guys, so now you have the ROSject link on the chat. If you click on this link, you will get a copy of my ROSject. Okay, so you are going to get a copy of this. A full copy of the whole code, notebook, simulations, everything that is included in the live class of today. So click on the link and then get the copy. It's going to take some seconds for you. So in the meantime, let me see. There is some Kirtan, hello. You are the best. Thank you. Thank you. So Jose says from Barcelona, robots, IAC. Oh, hello, Jose from IAC. It's very close to here where I am right now. And Dilip, how to map using leader. This is what we are going to see today. How to map using leader, Dilip. And Cheryl, oh, Cheryl, also, we were missing you, Cheryl. Now I'm happy that you are here. How to send the map to a web application. Okay, hi, Harryman. That's another question that we are not going to deal here today. And Naman, which ROS package to use navigation using Intel RealSense? Okay, so you can apply the same things that we are doing here for the Intel RealSense. You only need to connect to the proper topics. And okay, then it says, I have to create an account for this? Yes, of course, but a free account. So just create the account. Actually, you should have created before. Okay, so let's go again to here. Once you have the ROSject, let me go back. You should get some image like this. Click on it and then open ROSject. Okay, so just do that. And then in some seconds, you will get your machines. Well, it depends on the amount of people that is actually in accessing now and many other things. So it will take some, it could take up to 2 minutes, depending on the ones that are available. So let's see, in theory, it should be already connected. Let me see if we have any issue here. In case that no, it's connected to the remote services. Looks like it's correct. Let me just refresh just in case. And let's see. Okay, so it's connecting. In the meantime, let me check here the chat also. Then there are more questions. It says, Sam, hi, hello Sam. How to map using Kinect, Mr. Toxic. And Sandra Rivera says, hello, hello. Sandra, Mr. Toxic, about using Kinect, you have to, first, you have to convert the Kinect data into a laser data, and then you can apply what we are going to explain here. If you check in our channel, you will see a video that explains how to convert from a point cloud, that's what the Kinect is providing, from a point cloud and into a laser. So you can see, you can then afterwards apply what we are going to see here today, because here today we are going to learn about how to do a map by using a LiDAR or laser. Then let's go for that. I see many questions, but too many. So let's go for the class. Let's advance a little bit, and then I will go to the questions back again. Okay, so when you open the ROSject, you will get this notebook here open automatically. This is the notebook that contains all the instructions for the live class of today. Okay, so in case that you don't get that for whatever the reason, or you just close here, there is a button to close, don't worry. Go to Tools again and select the Jupyter Notebook. There it is. And then it will pop up again. Yeah, well, actually it shows you can have many notebooks, okay? So when you open the first time, it shows the default one. That is the only one that it has. But then afterwards, you can have more notebooks here. You can create as many as you want. There are some videos around there in our documentation how to create. But if you get that, then click on the live class 49, and that's all. There we are. So this is a class that we are doing in collaboration with Robotnik, which is a company that builds robots. Actually, we are going to use the robot that they sell. It's called the Summit XL. The Robotnik guys are super cool guys. They are very nice guys. They are so nice that they allowed us to have one of their real Summit XL that we are going to use on the next live class, okay? So on the class number 50. And of course, I highly recommend that you buy your robot at Robotnik. Actually, they have a ROS, it's called ROS Components shop, online shop, where you can buy any type of device for creating your robot. Even robots you can buy there, and all of them are ROS compatible. So they are not paying me for anything, that I just like so much what they do. And when I have to buy something related to ROS or to robots, I always buy to them. Well, anyway, so having said that, what is this class? It's about making a robot navigate. And navigate means to allow a robot to move by itself from one point to another while avoiding obstacles. So we are interested here in making robots move around by themselves, not joystick control, okay? And at present, we are concentrating on this live class about a wheel robot like this one that is equipped with the wheels, with odometry, and also with a LiDAR. I call a laser because I'm from the older school, so I call it a laser, but it's a LiDAR, it's the same thing. Okay, so what we are going to see today, it's what is robot navigation, already explained, how to do robot navigation with ROS, how. So we want to do robot navigation, but with ROS already provides many things to do it very easily, as you are going to see. Then we are going to see how to create the map for navigation and how to use that map to localize the robot in the world. And then for that, you need to know how ROS works. You don't have to be a master of ROS, but you have to understand topics and publish, subscribe, and that's it. And of course, you have to love robotics. Are you loving robots? Are you loving robotics? I hope so, okay? I will check afterwards. Okay, guys, so let's go. So in this case, we are going to use for this live class the Summit XL simulation that is from Robotnik. And in case that you like this robot so much and you would like to buy it, here you have a link with more information. This robot has equipped with many things: the 4 wheels, the laser ranger, the IMU, camera, GPS, and then today we are going to use only the wheels, the odometry that is provided by the wheels, and the laser ranger. You can do many other things with it. Actually, we have videos showing how to use the GPS and for localizing outside. So then about the ROSject already explained, and you can read afterwards. What is robot navigation? Okay, so robot navigation, what I explained, is to move autonomously in one environment. So the robot moves by itself while avoids the obstacle. And for that, we need to create a map of the environment, then localize the robot on that map. That means that the robot has to understand where it is in the space and where this position corresponds to the map that it has created. Then it has to be able to compute a path from a point where the robot is at present to another point of the map. It means the goal, the location where the robot wants to be. So the robot wants to reach that point. For that, it needs to compute a path, and then it has to also to have a controller that allows to move the robot following that path. And finally, it has to have an obstacle avoidance system that allows the robot to avoid obstacles. Because even if you have a path, maybe some people will interfere into that path, or some other things like, I don't know, a box that is left there by somebody, or I don't know, so a luggage or something, then it's interfering with the pre-computed path, and then the robot has to learn how to avoid that. Today, we are going to concentrate on creating a map and localize, and the next live class, we are going to do how to do all this together. And you are going to see that by using ROS is very simple. ROS provides something that is called the ROS navigation stack, that you have here an image that simplifies everything, but you don't have to understand this right now because it's too much. Just put in there the information to let you know, and if you want to know more about the ROS navigation stack, click on that link, and then you will see the whole explanation how it works. Then, today, what we are going to concentrate is on how to create a map and how to localize only those two parts from the ROS navigation stack. Both things are provided by the ROS navigation stack, so we don't have to create algorithms right now. We only have to learn how to configure the ROS navigation stack in order to create a map and to localize. Okay, so are you ready? I hope that you are ready. And the first thing that we are going to do is to have our robot, because we have to have a robot that is moving around. And let's go. Let's launch the simulation. In order to launch the simulation of the Summit XL, go here to the link here to this line where are all the tools, and click on simulations. Here you have a list of available simulations, and look for the Summit XL. Okay, so you see that there are many others robots. You will test that later. Concentrate now on the one that we have to do today here. I'm going to put it here. So now it's starting the simulation. A new window pops up. And in the meantime, let's continue with the notebook. The first thing that we are going to deal is about how to create a map. And for that, we are using SLAM techniques. There are many ways about creating maps. But here today, we are going to use the most common one, the simplest one, let's say, that is a SLAM technique, means simultaneous localization and mapping. And for that, we are going to use an algorithm that is called Gmapping. You can check the proper implementation of Gmapping there in the ROS packages and see the code. But today here, we are going just to use it. So we are going to use this. We are not going to program the Gmapping. Okay, so that's here you have more information, just in case that you would like to have more information about Gmapping. But we are going to concentrate on creating the map now. How can we use the Gmapping to create a map? Well, let's see. Here I see that the simulation has started. There are some errors there for some controllers, but they are not needed here, so don't worry. So it's going to work anyway. So here is the simulation. Here we have the environment, as you can see. Okay, I'm using the trackpad and not the mouse, and it's a little bit strange. So that's a simulation that created Fetch Robotics, and we are using it because it's very nice. And that's the environment that we want the robot to move around. Okay, so far so good. So let's go and let's create a map. What do we need to do for that? First is to create a package that will launch the map system, the mapping system. So for that, we have several things. First, in the tools, if you go to tools and then you select the IDE, then it's going to appear the IDE here that contains several workspaces here. Then, as you can see, there are different workspaces, and today we are going to use the Catkin workspace. The Catkin workspace is the one that contains, is a ROS workspace that contains the code that should be executed on board the robot. Okay, so here you don't put anything about simulations. You put the code that you will use in the real robot. So inside the source, as you may know, then we have to create our packages in this workspace, Catkin workspace / source. Then here we have other workspaces like the notebook one that contains the notebook of the live class, and others that today we are not using. So today we are only using the Catkin workspace and the notebook workspace. So let's go to our Catkin workspace. How do we do that? We need a shell. We need a shell. So let's go to the tools and select the shell in order to interact with the computer that we are using here to develop. Now you get this prompt here, user, and if you do an ls, you will see that all the workspaces here are the same that appears here on the Catkin on the IDE. You see all of them. Okay, let's go to the Catkin workspace. cd Catkin workspace / src. Now here we are going to create our package. Let's create a package named my mapping launcher. How do we do that? Okay, somebody answers. How do we create a package? What is the command? So any answer? I'm waiting here. Well, I see that there is a lot of interaction here. Then let me check while somebody says the answer. Then no answer to that. Okay, so let me tell you the answer. Are you sleeping or what? Catkin create package, that's it. Yes, Catkin create package. Yes, PKG. PKG. Yeah, exactly. Okay, I never remember exactly the command, so I just type Catkin, then tap, then you get this underscore Catkin create, and then PKG. Okay, that's the trick. It's a lie, I do remember, but just was telling you a way of going faster, okay? So then we indicate the name of the package, my underscore mapping underscore launcher. So please use the same names as we are doing here, because otherwise the demo will not work. Afterwards you can change anything. But I have prepared some copy paste, and then it will not work, the copy paste. So create the Catkin package, and then it should appear here inside the Catkin workspace source. As you can see, it is here. It is already here. Okay, very good, very good. Let's go inside this directory, my mapping launcher, and then create a directory. Let's create a directory. You can use it also the IDE to create a directory. Let me use that because it's simpler. It's right-click and then new folder, and call it launch. Launch. Okay, so yeah, sometimes the IDE takes some time to refresh. If it doesn't show, just fold it and unfold it, and there it is, the launch directory. Now, what we are going to do is to copy a file already provided in ROS, in a ROS installation, in a typical ROS installation. If in your system you have installed a package called Turtlebot Navigation, then you will have this file. Okay, of course, in the ROS Development Studio, it is installed. So you will see how easy it is to work this way and start making a map right now with any robot, almost. Any robot that has wheels with odometry and a laser, of course. So let's go to that package, Turtle Navigation package, and let's find inside that package the Gmapping launch file XML. So let's go. How do we go? Go ROS CD, and then the name of the package, turtlebot underscore navigation. Okay, so I have been moved to that directory. Then inside that directory, if I do an ls, I see that there is laser, launch, maps, etc. Let's go inside the laser. Inside the launch. And here, if we do an ls, we have Gmapping demo and AMCL demo. Okay, don't look at those ones. We don't need those. Go to the includes, CD includes. And then there, we do an ls again, and then we have AMCL and Gmapping. Okay, let's go inside the Gmapping, CD Gmapping. Okay, let me put it here like this. It's easier to watch everything. Okay, so look at the whole directory that we had to go. And then here we do an ls. Now here we have this Gmapping launch XML file that I mentioned here. Okay, check for the launch file name Gmapping launch XML inside this package. Okay, so that's it. We got it. Then copy the contents of that inside the file, my mapping.launch file. Okay, so yeah, I skipped that step. That it's here in the one. Later, when you read the notebook, you will go step by step. I'm going faster to have time enough. But so inside the launch file, we should create a directory named launch, and then inside create a file named my Gmapping launch. And then in that file, Gmapping launch, we had to copy the content of Gmapping launch XML. Actually, I'm providing you a faster way of doing it. That is this command here. What this command is doing is just copying the Gmapping launch file that we have here, this Gmapping launch file XML, into our directory of my mapping launcher.launch with the proper launch name. Okay, so what do we do? Well, we copy this command, whole command. You can copy this, copy Control-C, and then go here and Control-V. And this is going to make a copy of this file into our package with the proper name. Okay, so let's do. This is a very simple Linux command. I mean, I'm not showing you anything fancy, as you can see. Okay, great. Then, if we go to the IDE, we have here inside the launch file, if we open now, there is this Gmapping launch file. Open it, double click here on the IDE, and there it is. So we have this file this is a file that is provided for the Turtlebot navigation package. What we are going to do is to use this one, just configure for our robot, and then launch it. That easy. Now we will have very fast a robot creating a map. You're going to see in a second. It's very fast. It's very simple. So that's the content of the file. I put it there for your own benefit and for your better understanding. We don't need to use it because we already have it here. Okay, so just for understanding. And then what is interesting here to understand is how do we configure this for our own robot? Remember that this procedure you can apply later to your own robots. So to any other robot that has wheels with odometry and a laser, and you can do the same things. Okay, so the important things that we need to configure are those points here, those arguments here. The scan topic, the base frame, and the odom frame. Those are here provided as arguments. And then what I recommend you is that you modify it here, yes, here, by the proper names. So in this case, the scan topic is in which topic is the robot publishing the laser data. So which one? For the Summit XM Excel? We don't know. How do we know? How do we check? We go to a console here, and then we do a ROS topic list. Let's do a ROS topic list. Something like a scan or something like that should be publishing. Let's check here, no. Here, Hokuyo-based scan. Because I know that Hokuyo is a type of laser. And then scan, then, okay, so it looks like it's this one. If you want to check even more, you can do a ROS topic info. So let's do a ROS topic info of that one, and then you type the name of the topic, Hokuyo base scan, and then it will say, yeah, I'm publishing sensor messages of type laser. That's it. That's our topic. Let's go for it. Then we have to put that topic here in the configuration file where it says scan topic. So remove the one that is there. Let me remove and put instead the one from the Summit Excel, Hokuyo based scan. Okay, so far so good? Great. Now we have to modify also the base frame. The base frame is the frame that identifies the center of the robot. So it's very common that it's called base footprint, but we have to check if in our robot it's the same. So this is published by the TF. So in the topic TF, we should see that which one is the base frame, the frame that is at the center of the robot. And then we also have to know which one is the odom frame. The odom frame means the frame at which the odometry is being published. I cannot go in detail what that means. If you don't understand that, then you need to learn more ROS basics. Okay, so that means that it's the frame of reference at which the odometry is being published. So how do we check that? Well, very simple. There are many ways of doing it, but the one that I like the most in my case is to launch the RBase. So let's launch the RBase. You know what is the RBase, isn't it? It's a visual debugger for ROS. It's visual representation of information in ROS. It's very useful, a very good tool. So for that, ROS run RBase. If you do that, then it should start the RBase, and there it is. We got the RBase, and now where is the window of RBase? So it only says that. No, we should see this window here with some values there. Maybe not that visualization, but the RBase window, and where it is not here. In order to watch any window that ROS is opening, because we are using this web browser system, we need to go to Tools and then select Graphical Tools. Select that one, and then in a few seconds, it's going to show, there it is, RBase. Let me put it bigger. Actually, I'm going to make it occupy the whole area. There it is. And also here, you can see that the RBase is not properly centered. You can go here to the blue area and do a double click, and then we'll double click, and then it will auto center. Okay, great. So what do we need here? I'm going to remove this. First, we need to add the robot. Let's add the robot. So we go to add, and then select here in this list. You have to select the robot model. Okay, you go looking, it's at the bottom. So select robot model, okay, and then it appears here as white. Why does it appear like this? Well, because the fixed frame, the frame at which everything is being represented, it's called map, but map is not still being launched. So we need to here modify, click here on the fixed frame, and then select, let's say, for example, base link, for example. Now our robot appears because base link, he understands what it means, which frame it is. There it is, the robot. Now we need another thing. In order to watch the frames, we need actually we can see them here in the list of frames. So there is the base link and there is the odom here. So That means the base link is the center usually in a robot, and then the odom usually is the odometry. So we can know now that those are the values that we have to configure the Gmapping. But in case that I'm not sure, I want to be sure, 100% sure, okay, then go here to add, and you have to add the TF. So go down until you find the TF. It's almost at the bottom also. Here it is, TF. You add TF, and then all the frames, they do appear there. Okay, now you can see all the names and too many things there. I'm going to untick here the robot model. If you remove the tick, then the robot will disappear. And then you can get closer and read the names. Okay, so yeah, you can see that the base footprint is there. Then the base link is there in the middle. So yeah, I know that you cannot see. So if you want to see, click here on the TF configuration, and here on the frames, it says all enable. Then uncheck that one, and then just print the ones that you want to see. For example, the base link. Now here, typical base link, and then also let's put the odom. So the odom is there, and now if we click again on the robot model, you can see where it corresponds to the locations of the robot. Okay, you can see that the base link is on the center of the robot. Yeah. So base link is there, and odometry is just beneath because the robot hasn't moved yet. When it starts moving, then the robot will be away from the odom, of course. The robot is still there. Okay, so we know base link and odom. Let's go back to our configuration here, and then we have to say here base frame, base link. So you can go here and select and say base link, and then odom frame, already odom, that's okay. Okay, so basically that's it. I know that there are a lot of other parameters here, and you can play with them, but usually the default values already work, usually. So you will have to play with them. I'm not going to explain all them, just this demo for making it work, because we don't have time, yeah? Okay, so we got it. Then let's start making the map. So for that, we have here in the graphical tools, wait, I'm going to put it here, the graphical tools, here. Yeah, and then here I'm going to launch another the mapping system. So I'm going to launch another shell here on tools. Go to tools and open a new shell. In this new shell, we are going to launch our mapping launcher. So remember, we have created this package and this launch file, and that's it. Then the system will start to create the map. So let's copy that command or type it as you want. Actually, it's very simple if you do tab. So just in the new shell, type the command for launching your launch file, the one that you had created there. And by launching this, you are activating the Gmapping algorithm, and your robot will start making a map. Okay, so you can see here it says registering first scan for the mapping, and here the SLAM Gmapping node that has been started. Great, we are there, but almost there. Still not. Now we need to move the robot around the environment to make the robot create the map as it moves. For that, we need to use the keyboard teleop. So we need another shell. Go to tools, shell, and let me put it here, and a little bit like this, smaller. And you can launch this command that is for controlling the Summit XL using the keyboard. Okay, so you can copy that command and put it on the other shell. This is launching the keyboard control of the robot. So now you can see that there are, to moving around the robot, use those keys here. So if let me show the simulation again. So it's here. Great. So we have here the robot, And let me put it like this. So I'm going to press here the keys, and you are going to see that the robot is moving, starting to move. So I'm going to press I, and then the robot is moving forward. And also some things are happening on the RBS. We are going to go there. So if the robot doesn't move for you, remember that in order to have access to the keys, you have to have the focus on the shell. Focus, complete focus. I mean, this is blinking in white, okay? So now you can press the keys and make the robot move around. Okay, so I don't know what he's doing here. This. Okay, so there it goes. There it goes, and it moves around, it turns. Yeah, okay. Okay, so the robot is moving around, and then the algorithm here, it's doing some things, but how can we see the map? Very simple. Let's go back again to RBS. Let's go to RBS, and let me put it bigger in full screen. And now I'm going to go back and move like this. Yeah, so you can see, as you can see, we have moved from the autumn frame. Yeah, that's normal. Okay, great. Then here, let's add a map. Let's visualize here in RBS a map. So for that, go to add, and then move down, down, down until you see map. Map, you include the map. And now we have to configure the map. Okay, that's why still you cannot see anything. For configuring, very simple. Open here the map configuration, and where it says topic, click here on the side and select the topic of the map that it appears here, map. There it is. And then press enter. Oh, sorry, it took the enter took the whole, and then you can see that it appears the map that the robot is creating. Okay, very good. So far, so good. Then now, what is your turn? Your turn is move the robot around and create the full map of everything. So for that, let me put it smaller. Let me also remove the configuration panel to the left so we can see only the map here on RBS, how it is being created. And also the perspective, I'm going to change it so we can see from the top. And now I'm going to configure here, to show here the simulation so I can see what is actually doing the robot in the reality. Yeah, okay. So let's move it a little bit, okay? Not the whole area because we don't have time, but let's move it a little bit. So remember to select the shell again and start pressing keys to move the robot around. Okay, if it goes very slow, you can increase the speed by pressing Q. I'm going to increase the speed and now go faster. Okay, so the robot is moving and creating the map of the environment and going forward. Now I'm going to turn to some place. Wow, I'm moving too fast. Hey, okay, don't go so fast, my friend. Okay, now it's going, yeah, I think I increased too much the speed on the turning, but okay, so far so good. So I'm moving around and creating the map. You can see that the actualization of the map is not happening in real time, yeah, because we don't need it. So it's made every some seconds. It's a parameter that you can tune also in that file. So you can check afterwards. Okay, so I have created a map of this area. So that's good enough for this demonstration. Now, I have created the map, and whenever you are happy with the map created, then you have to save it. You have to save it because we want to use it afterwards. Okay, so let's go and save it. How do we do that? We have to execute a command that is here. You can see here on the saving the map. Yeah, then let's open another shell. Yes, I know, another one. Yes, come on, it's for free. Just launch more shells and use them. Okay, so you have the command there, but basically it's map saver. We have to use the map saver. For that, let me tell you one thing, what we are going to do in order to make it simpler. Let's go to the my Gmapping launcher package, and let's create a config file there. So we will store there the map that we create. So let's go cd catkin workspace source, then my Gmapping launcher there, and then here let me create a directory. It's mkdir, and let's call it config. Then let's go inside the config. And now here, let's execute the command for launching the saver of the map. That command, as you can see on the notebook, is ROS run map underscore server, then map underscore saver. Okay, then -f, and then the name of your map. For example, my underscore map. By doing this, the map will be saved. And then if you go to the IDE here, again, if you open the IDE and go to the mapping launcher, you will see that there is a config file, config directory, and inside is the file of the map. So we got the map. Okay, congratulations if you reach that point. Great, we got the map. Now that the map is done, we don't need anymore the Gmapping node. Okay, because the map is done. Then for the future navigation, you can kill here the program that makes the navigation, the mapping. So you can press here, Control-C, and stop it, because the map is done. Okay, so far so good. Let me see how it is going. Let me check the questions there. Let me see. Oof, many questions. Let me see if I can get it. My God. Okay, can create, yes, package. What's the difference between CD and ROS CD? It's a question by Cheryl. The CD is a Linux command. So you change from one directory to another. But ROS CD allows you to go directly to a package location. So CD, you need to know the complete route where you want to go. But with ROS CD, you just want to know the name of the package. And then by doing ROS CD, the system will bring you there directly. And CD, yeah, so Lagan has explained. And Lawrence also, very good. I lost connection engines. Uchena says, if that happens to you, just press this button. It depends on the connection. So if you sometimes lose the connection, you can press this icon here that is kind of resync. It's resyncing and finding again connection. So press that in any of the windows. You can see that this icon is there. Use that one for resyncing. More questions. Sorry, can you back up to how you detect the laser topic? My ROS topic list doesn't not show any laser topic. No, it has to, Commander Cisco. So it has to be because it's the simulation who is providing the laser, and the simulation, you don't control that. It's the system that has generated the simulation. Then Danida says another way is ROS run TF view frames. That's correct. That generates the PDF with all the frames. What is shown in topic list? What is shown in topic list is the list of all the topics that the robot is publishing. Okay, and then ROS topic list. So you have been answering. Gazebo has gone on a strike again, just like last week. It's saying no simulation running, and I have refreshed it many times. If that happened to you, Commander Cisco, try to launch again the simulation. And also, if that happens to you, it's very, very, very strange, really. And second time, it means that either you are not using Chrome or Firefox. It's one of those. Or your versions are very late, very old. Why map in Arbis rotate? I think that, no, it's rotating the map in Arbis. It's myself who is doing that rotating by clicking and moving around. So because I want to change the point of view for visualizing. Is it possible to map with only LiDAR and no odometry? Yes, it is possible. There are many algorithms that do that, but in that case, we are using the simplest one that uses odometry. Can you show us your RTT graph? Yes, if you are a U-type RTT graph, then it will open on the graphical tools window. So it will show you there. So you can launch any RTT application, and then it will appear on the same window as the ROS. I'm using Chrome, Commander Cisco. Okay, we have to check that. We have to check that because that's not normal. Please, Commander Cisco, launch again. Launch again about the simulation, and let me know if that works for you. Okay, let's continue. So we have the map created. Now we need to provide this map to any navigation program that we are going to launch, for example, the localization one. So how do we provide the map that we have created to any navigation program? For that, we need to launch this command that is included here in the notebook, providing the map. Once you have killed the mapper node, remember, you have to kill the mapper node. You don't execute that without killing it because there will be conflict. So now you launch this command where you are providing here your map file. Okay, so let me put it as better here. Remember that I went to that directory and I saved my map with map server, map saver. Now, in this same directory where I have my map files, I'm going to launch this map server and I'm going to indicate my map. So that is going to publish the map for any navigation program, the map that I have created. So let's do it. ROS run map server, 2 times. Map server is the name of the package. Map server second time is the name of the binary. And then we provide the name of our map, the YAM file. In this case, is my_map.yam file. Now, this is something that has to be running every time that we need to do navigation, and is the server of maps for any navigation program. Okay, we got it. It's there, it's running. And now let's launch the localization. In order to localize the robot, we have to do something similar like we have done with mapping. It's very simple now, again. So let me go a little bit faster because you know the procedure. So we go to the same directory that I explained before, but instead of copying the Gmapping XML file, we are going to copy the AMCL launch file. AMCL is one localization algorithm. It's one localization. It's called Adaptive Monte Carlo Localization. Okay, so that's the name. That's why it's called AMCL. So first, we need to create a package in our Catkin workspace. So let's go to in one of the shells that it's open. Let's go Catkin source, then Catkin create package. A package, then my_localizer launcher. Then this is going to create that. And then I'm going to get inside there, my localizer, and I'm going to create the launch directory, mkdir launch. Now I'm going to go again to that location, Turtlebot navigation, where the AMCL launch file is located. So for that, I do a ROS CD. Remember, Cheryl, this is going to bring us directly to the package, wherever it is in the hard disk. And the name of the package is called Turtlebot navigation. So you have to put ROS CD and the name of the package that you want to go. So as you can see, my directory has changed to a very different one. Yes, so that's because ROS CD has done it. And I don't have to remember all that. I only have to remember the name of the package. Okay, so then here, I don't remember, but it was in launch. then CD launch, then include, then AMCL, there it is. And here we have the AMCL launch XML. Once we are here, we can copy this command that is copying the AMCL to our package properly, with the proper name and with the proper everything. So let's do it. There it is, copied. Now, if I go to the IDE, I can see here inside the source, let me refresh it, that I have my localizer launcher. Inside launch, I have my localizer.launch. And if I open it, then I have this file that is about the localization with many, many parameters again, but only some of them need to be configured, are the ones that are explained here. So here is the file, the ones here. Again, the scan topic, where is the laser, the base frame ID, again, the odom frame ID, and then there is another frame ID that needs to be configured, that is the global frame. That means which one is going to be the frame for the information of the map, that the localization of the robot is going to be referenced to that frame. Okay, and in that case is map. Odom is also again odom. Then base, in this case we have base footprint, so I put base link, but it's okay. So it's the same value that we got here, base link. So we can change here to base link. And then we have to change also the laser, because the laser is being published in another topic. That's let me copy it here from the previous file that we did for the mapping. So I'm copying here, and then I configuring here also Okuyo base scan. Now, the rest of the parameters, and you can leave them like that. So it will work. And then once we have that, we are ready to launch it. So if we launch this command, then it's going to launch our package with our configuration. And it's going to launch the AMCL. You can execute that in any place, okay? So anywhere. There it is, the AMCL is starting, and some things are happening here on the RBS. You can see here, okay? So it looks like everything has started again, but as you can see, the robot is located here in the map, and if we go to the simulation, let me go to the simulation, we can see that the robot is not there. So it's not corresponding the location of the robot here. Let me show you the map, the whole map. Okay, so wait, I have to get a little bit back. So yeah, so this is kind of the corridor, you know, the corridor that is here in the simulation, but the robot is not there. It's actually close to this column, that it would mean close to here, to this area here. And why is that? Well, because we have just initialized the localization. So the system doesn't know where the robot is when you just started. Then we can help it. Let's help the localization system, and let's provide to it close to realities, as close as possible to the actual position of the robot in the simulation. Yeah. So how do we do that? First, let me show you how to visualize the information of the localization system. So for that, let's go to the config of the RBS here again. If you close it, open it again, and let's add another element. In this element, it's called, let me show you, it's called the pose array, and it's here located, pose array. So if you select this pose array and then press OK, now we have to configure to tell, hey, please read the information from the topic that provides the AMCL. So you select topic here, and then, oh, let me put it bigger so you can see better. Yeah, so I have added a pose array by clicking here, and then I'm going to the topic, and here, let me select the AMCL, that is called the particle cloud. You select this, press enter, Oh, okay. So yeah, so the particles should show already. It's not showing. Okay, let's move the robot. Okay, maybe it's because just very short amount of just started the algorithm. So let's move it. Go again to the shell where you had your keyboard for moving the robot, and let's move it a little bit forward. So we should see here. Okay, there are the particles. Okay, so those particles are indicating possible locations of the robot. So at present, the localization system thinks that the robot is around there. It's in some place there, but we know that is completely wrong. Actually, has crashed against the column in my simulation. Okay, so let's do one thing. Let's provide this information to the localization algorithm and let's help it a little bit. How do we do that? Here in RBIS, put it bigger. Here in RBIS, there is an option that is called 2D pose estimate. If you press here, then you can indicate in the map where the robot is located, actually. And you can select that it's around here and then press without releasing, move into the orientation that the robot is. So in which direction the robot is looking, that is against the column. Okay, so let's do that. And it has done nothing. Yeah, I know why. Because we need to change the fixed frame. So remember at the beginning that we changed the fixed frame to base link. Now we have to put it back to map. So select map here. That means A, particle systems, localization system. The pose estimate that we are going to provide you is in map coordinates. That's correct. So let's do it again. So once you have changed to map, go again to 2D pose estimate, then go here to the column and select and do it like this. And there it is. So the particles are now there, spread around that location, and the robot is also located there. If we move now the robot again, let me move it here, I'm going to move it backwards, then you will see how the particles, they start to concentrate more and more, and that is indicating that the robot is actually well localized. And you can see it corresponds to the proper location of the robot. So let me move it a little bit more backwards. And the particles are concentrating into a location, and then the robot is starting to say, oh yes, I'm crossing in front of the door, I'm crossing now in front of the corridor, and that's it, so I am there. Okay, so now the robot is located, properly located. So we have localization on mapping done. And from that is what we are going to build next week, in order to use localization and mapping to make the robot move forward and move autonomously, to create path plans and all that stuff. Okay, let me check the notebook if something missing. Here it is about that. Yeah, and that's it. No, that's mission complete. So we are going to stop here. Just want to remind you that give us a like. If you like the class, please, that's helping us a lot. If you say thumbs up in the YouTube video, and of course subscribe to our video channel, because we are publishing new videos every day about how to learn ROS and different aspects. And I would like to tell you about the second ROS Developers Conference that we are doing. It's in June, in 15 and 16. It's a conference that is online. So in order to attend, the only thing that you have to do is the same thing that you have done here in this live class, is to attend to a channel in YouTube, and then there will be 8 experts. It's not going to be me, but 8 experts from around the world that will teach you some other subject about ROS in the same way as we are doing here. So it's going to be a full weekend with experts. There will be a chat room where you will be able to speak with all the attendants, with all the people that is connected from everywhere of the world. That's the second time that we are doing it. That's the second ROS Developers Conference. And we did last year also. You can check the videos here or the previous, and you can check how it is. So there is a complete list. And no, sorry, there is a problem in this link here. Oh, okay. I put here. Okay, so I forgot about this. But anyway, so here in the ROS DevCon, this is the link of the conference where you can register for attending, or if you want to speak at the conference and you can provide a class to the rest of the world. Of course, there is the option, and you can find all the information here about what is required if you want to register, and if you want to check the previous year videos. It's here. It's let me check, where is it? It was around here. Okay, so I cannot find it, but it was here. I think it was. Okay, so yeah, so it should be here, but it's not. So I will check it and provide that to you on the next live class. Okay, so that's all for today. And let me see if there are any questions. I can dedicate some minutes for the questions and go to there. Hello guys, I'm back here. Let me check questions. Let me go from bottom to top, okay, because there's too many things there. So there is here Guillermo says, how can I get a leader for the simulation of Turtlebot 2? And then Cosmas is providing you, Guillermo, with a solution. Yeah, so actually the Turtlebot 2, it's already providing, if I remember correctly. No, it's not. Okay, so you had to add a Hokuyo robot for that, a Hokuyo laser, sorry, for example. That's an example. And we have a video in our channel about that, about how to add Hokuyo into a Turtlebot. So check it. Check in our channel, check Turtlebot laser, and then you will see the video that explains how to attach this with the links, etc., to the simulation. Okay. Cosmas says, how is Odom provided in here? Using the topic or the TF? So it's using the topic. Well, it depends. It depends on the localization algorithm, yeah, and also on the Gmapping algorithm is by using the TF. By using the TF. That's why you have to configure the Odom frame, and you don't have to configure the Odom topic because it's getting the data from the TF. It's a very good question, Cosmas. Then Rishabh says, the dev image to laser scan package will generate a scan topic for Kinect. That's correct. Danny does. The thing about leader is that only detect in the plane, so only objects in a specific age. That's correct, Danny. Okay, so I think that I am reading some answers that you have already done. Okay, so let me see any. Gloria says, yeah, this is my first SLAM navigation map ever. That's very good. So you got the map. Did you get the localization working also? Okay, I would like to know. Then, so you are asking some questions again between you. Then, let me see. And also how to add more sensors like ultrasonic sensors or rangefinder in order to improve obstacle avoidance. Oh, yeah, I see the original question. Ricardo, could you give us some tips about how to effectively merge data from a LiDAR and a depth camera? Let's say Hokuyo and Intel RealSense. Yes, but so then, so you want to, it depends on what you want to do. It depends. So for the SLAM algorithm, you only can, for the Gmapping in this case, you can only provide the laser data. So in case that you would like to use the depth sensor and the laser, you can do it, but you will have to convert this depth sensor into a laser. And then afterwards, for example, you can fusion both the laser and the Kinect data into creating kind of a single laser. And that's very interesting because it will provide you like obstacles in 3D, but in a 2D representation. in a 2D representation. So by this, you can do a slam in a 2D, but taking into account obstacles that are a higher directions. Another option that you could do is to use, for example, the laser only for localization, but then the Kinect for obstacle avoidance. You can use that. Then, because the Kinect can detect obstacles in 3D, and then you can provide this information into the obstacle avoidance algorithm, into the move base, so it can create a course map of those obstacles that are detected by the Kinect. I cannot give you a tip directly, but let me think if there is a course where we explain that. I think that. I don't remember now, but I think that we have a course that explains that. What we do have is also another, it's a complete 3D SLAM algorithm that is called RTAP. And this one uses just the Kinect. So you can use just the Kinect for creating 3D maps of the whole environment, in the same sense that we have done here for SLAM. So you can do it for 3D. And then you create a map that is the complete environment in 3 dimensions. And then the robot navigates using that. We have a course, it's called RTAP. It's already available online, and you can practice there. It explains how to configure that for your Kinect. Then Escamiambas asks a question very interesting that says, what's the point in mapping to avoid obstacles? And that's very good question, Escamiambas. So when you create a map, in that map usually contains many of the obstacles that are fixed. So for example, if there is a table, usually that table will be always there. If there is, I'm talking in general sense, the doors, there are the walls, they will be always there. So you can use this map for creating paths that avoid those fixed obstacles. Then, apart from that, afterwards, when you start the obstacle avoidance algorithm, then this one is going to also scan additional objects, for additional obstacles that are new, that were not included into the map. And this obstacle avoidance is going to include those new obstacles inside the map, like on top of map. You will see it's called a cost map. It's what is called as a cost map. But basically, it's the map that you have created plus the new obstacles. So you are putting on top. Then the path planning is going to plan, instead of planning on the original map that only contains the walls and the fixed obstacles, is going to plan on this extra map that contains the original map plus the new obstacles. I hope that this is a little bit difficult to explain just by talking, but I hope that you have understood. And it goes and goes, and I'm sorry, but we have to finish here. I cannot answer all your questions. That's the first time that happens, and in the live classes. I'm very happy that this class has created so much interest. So what we are going to do is to plan more about that subject, okay, and let you know. So please, in case that you have questions that you need the proper answer, put it below the comments here on this live class. When this video is going to be published in a minute, it will be available. So go there and publish it, and then peacefully, I will answer all of them. I promise to answer all of them, okay, guys? Okay, so thank you very much, guys. We have to finish here today. It's very late already, and I hope that you enjoyed the class. And remember that we are going to have another class next week about using what we have built here today and make the robot move around. And we are going to use a real robot. So we are going to see that on the simulation. All of you are going to practice on the simulation the same way we did today. You are going to practice on the simulation, and then some of you will be able to connect to the real robot that is going to be here. It's going to be the real Summit XL that the guys of Robotnik, they have provided to us for doing this special live class. And so you are going to have the chance to connect. It's only going to be for 5 of you, only for 5 of you, and it's going to be the first 5 that indicate on the comments of the video, I want to practice with the real robot. then only for 5 people. So you will be able to connect to our robot directly from your location. That's cool, guys. That's very cool. From your location, you are going to connect to our robot, and you are going to control it directly by using the ROS Development Studio. Okay, and all the things that we'll do around that live class. So if you're interested, please, when this video is published, go to the comments and say, hey, I want to be testing on the real robot next week. And then you will get your spot. And when 5 people have said that, then it's full. Basically, because we don't have more time. I would like to provide this to all of you, but we don't have time for all of you. You are so many there. Okay, so that's it. Thank you very much. Thank you, Matt. Very good. Thank you, Junjuan, Danny Dask, Mr. Toxic, and Construction 3D. And yeah, so all the people there, that you are so many. Thank you very much, guys. See you next week. Bye-bye. Remember, I'm not that one. Can I close this? I cannot find the window. Okay, too many windows open, you know. Now, yes. Bye.